Hello, ladies and gentlemen of the internet. My name is John Major, and today we're going to be talking about FlexVPN. So, with FlexVPN, in this video, we're going to do site-to-site tunnels. And not only are we going to do site-to-site tunnels, but we're also going to have dynamic spoke-to-spoke tunnels. And not only are we going to have dynamic spoke-to-spoke tunnels, we're also going to have certificate-based authentication, and the certificates are going to be issued by our Microsoft Certificate Authority. I'll do a separate video showing you how to set up a iOS router as a certificate authority. That way you don't have to have the Microsoft CA. If you want to use the Microsoft Certificate Authority and you're not sure how to set one up, I did a setup in my WSA series. I think that part 1 is when I did the certificate authority setup, which was for the web security appliance. And I'm actually using that exact same certificate authority for these videos. So, without further ado, let's go ahead and get our certificates set up. I have the topology right here. I did want to point out that the spokes all have dynamic IP addresses, and the hub has a static. The hub could be DHCP also, and I'll show you where you configure that on the spokes. So let's go through. So I also want to point out that a lot of these configs are repetitive. So I'll show you how to set some of this stuff up on the hub first. Like getting the certificate requested is very repetitive. So we'll go through setting it up on the hub. I'll point out what you have to change on the spokes so that you just sort of paste on all of them, and I'll speed that part of the video up so you don't have to watch me do the same task over and over and over again. So the first thing that we're going to do is we're going to do IP domain name. I'm going to be in nerd.local. I'm going to do crypto key generate RSA. Modulus, we'll just do 1024, and we're going to give it a label so we can keep track of it. The label will be flex RSA. All right, that's done. And so this stuff will all go on our spokes. Put that in Notepad. Then we're going to do crypto Pki Trust Point. We're going to set up our trust point for the Microsoft Certificate Authority. We'll give it a name. How about EntCA? How's that? And the fully qualified domain name for this router is going to be hub.nerd.local. We have our subject name is an X509 format, so subject name is CN equals hub.nerd.local. I'm just going to copy and paste that part. Comma, the organization, or O, equals nerd. The organizational unit, OU, equals, how about NOC? And let's see, the state is North Carolina. Location, we'll say is Raleigh, and the country is US. So up here, we created this RSA key called Flex RSA. We're going to tie that in down here by saying RSA key pair is Flex RSA. We need the fingerprint of our root CA. The way that you get that, we're going to jump over to the CA really quick, is you're going to go into Certificate Authority, that MMC. You're going to drop down to your CA right here, that server. We'll right click on it, go to Properties. Brings this dialog box up. We're going to stay in the General tab. We click on the certificate. We click View Certificate. We go to the Details tab. We scroll all the way to the bottom and we look for thumbprint. We take the thumbprint, we copy it. Bring this back over here. I'm going to create a new notepad for that and scoot this over and reorganize things. All right, so there's our thumbprint. I'm going to go ahead and just remove the spaces. Replace with nothing. Okay. iOS always gets mad when I copy and paste this the first time, but we'll try it anyway. So I'll say fingerprint, paste that in. Yep, gets mad every time. All right. Fingerprint. All right, so that's there. Let's do a do show run, see where we're at with our PKI config. Bum, 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 bum. All right, so we have our FQDN, we have our fingerprints, we have our subject name, we have our RSA key pair. Revocation check, we're going to set that to none. Actually, what are your options there? Yeah, I don't have an online responder. Yep, we're going to set it to none for now. All right, and I do believe that's it. All right, so this, by and large, can be copy and pasted to all of our spokes. We're just going to be changing the FQDN from hub to S1, S2, S3, S4, etc. And same with the subject name. But the rest of it is all good. All right, so we have to authenticate this PKI, which is going to require the root certificate. So we're going to copy that to file. Again, I have the same dialog box from seeing properties of our CA and go into the certificate. Once you get to that details tab, you can do copy to file. And it's going to want it in base 64 encoded format. We'll just drop it on the old desktop. I'm going to call it root CA. Ah, and I forgot a step. So under our trust point, we're going to have to do enrollment, if you can spell it, is terminal. And then we want the PEM formatting. Otherwise, we won't be able to use the enrollment, the output from the enrollment. So we'll put that on the hub here in a second. I just want to get this copied. I don't need that anymore, actually. So this certificate right here is the base 64 encoded certificate of our root CA. So let's go back before we try to authenticate this bad boy. We'll go back into the trust point, set enrollment to terminal. This will output our certificate requests to the terminal, and by default, it won't put it in PEM format. It won't put it in the PEM encapsulated boundaries as I read from the screen. So we want to go ahead and specify that. So we have enrollment terminal PEM. Now we're going to do crypto PKI. We authenticate it. That was EntCA is what we call that trust point. And now it's asking for the base 64 encoded certificate, which is what we just copied off of our root CA. And we'll pop that into the terminal. We type quit on a line all by itself. It checks the certificate against the thumbprint that we put into the trust point. They match, so we have this authenticated successfully. Now we have to actually enroll our certificate, which is going to generate our certificate request that we actually put into certificate services to get the identity certificate for this router. So far all we have is the certificate of the root CA trusted on the hub, but we don't actually have a certificate for the hub to use. So to get that, we do crypto PKI, and now we're going to do enroll. We're going to enroll EntCA, our trust point that we created. It asks us a couple questions here. I don't want to include the serial number. I also don't want to include the IP address. I do want to output the request onto the terminal here so I can grab it. I don't need to have it redisplayed. So I'll copy all this, go back over to my CA here. I can minus some of this stuff down. All right, I'm going to go HTTPS, localhost, certserv, continue. I'm going to request a certificate. Go to advanced request. I will choose to submit a certificate request by using base 64 encoded and many more words after that, but this second option here. I'm going to paste the request that I just generated on the hub in here, and then certificate template is not set up yet. Dun, dun, dun. All right, back out of this for a second. So we are going to use the Ipsec offline certificate template. You can technically do the user one. The problem with the user one is it messes with the subject name, and it'll still sort of work, but it doesn't give us the level of security that we're looking for here. So let's go to certificate templates. Again, this is in the same certificate authority MMC that we opened up earlier. We're going to, again, go to this bottom thing, or this bottom option here, certificate templates. We're going to right click, go to new certificate template to issue. And we're going to come down to Ipsec offline request. Drop that in there. And I'm logged in as the domain administrator, so I don't have to worry about the security settings on that template. So I should be good to go. Now I can just go back to submit request to the CA, make sure the template's there. It is, so I select Ipsec offline request. I paste in the request generated by my hub router, and I click submit. I click yes on this dialog box. It asks me if I want to download the certificate in DER or base64. We're going to download it in base64. Just the certificate's fine, don't necessarily need the chain. And I click save. I'm going to open that folder. And here's my certificate. I'll go ahead and copy it. So it's just my clipboard. So let's complete this certificate request. Right now you can see the status of this. If you do show crypto Pki certificate, I don't want to do storage. I think we just do that. There's the CA certificate. Let's do verbose because it should have our request in there as pending. Bum, 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 bum. Not even. Yeah, normally it shows your certificate as pending. At least I thought it did. All right, so let's complete the enrollment here. We'll do show crypto. I'm sorry, we'll do from global config crypto Pki import. And the trust point was NCA, and we're importing a certificate. Press enter. It asks for the base64 encoded certificate, which we got that from the CA. We just downloaded that. I'm copying that in my clipboard, and I paste. Like Mexico. Now quit on an empty line. Import was successful. Now we'll definitely get an extra certificate. If you notice above when I did show crypto Pki certificates, the only certificate on there was the root CA's certificate. But now if I do show crypto Pki certificates, now you'll notice there's another certificate marked as available, and the subject name is hub.nerd.local. And that's good. So we are done on setting up the certificate on the hub. So now what I'm going to do is change this. So the next router we're going to do is site 2. You'll notice I am doing this all in IOSV. So site 2, I'm going to do the same thing. I just need to pop out FQDN is S2, and on the subject name, CN equals S2. Can I make that font bigger? Not easily. You'll have to squint. So that's all I'm going to do here. I'm going to go ahead and just start speeding up the video, and then do the same thing on all of the routers, where changing FQDN and subject name, and then doing the certificate enrollment process. And stop. Okay. So now all of our routers have certificates issued by the same trusted certificate authority. We'll go through and just make sure everything looks good. We'll do show crypto Pki cert and site 5. All that looks good. Let's just go check it on all of our routers really fast, because I want to know now if there was anything wrong. Bum, bum, bum. Just go through, copy and paste action. Already checked it on the hub. Site 2, name looks good, CN looks good. Site 3, name looks good, CN looks good. I'm also checking to make sure status is available. But name looks good, CN looks good on site 4. And on 5, name looks good, CN looks good, marked available, looks good. Okay, so let's get into the FlexVPN configuration. To do that, we're going to go back into global config. The first thing I'm going to do, because I will forget to turn this off if I don't do this, I'm going to do no crypto Ike V2 HTTP URL cert, because we're not going to be doing any certificate lookup based on any certificate lookup based on HTTP based URL. So just turn it off. We're not going to use that. We have a couple options here for setting up all of our encryption parameters. Just to show you really quick, iOS comes pre-packaged, and this is for your ease. with a few crypto parameters to save you all the typing. I'm going to do all the typing because I think it's interesting to see all the components that go into this. If you were doing this in production and you weren't going to be doing any Ike V2 except for FlexVPN, you are totally welcome to use the defaults. The defaults being, if we do show crypto Ike V2, we'll look at the authorization policy. There is a default authorization policy. You can totally modify that and use that. We do show crypto Ike V2 proposal. There's a default proposal. Has some nice crypto parameters in there. And I don't think there's a default profile. Yeah. One sec. So we looked at the authorization policy. We looked at the policy. There's usually another one that I normally look at, but I'm totally forgetting what it is. It doesn't matter. I'm going to configure it all from scratch. You could use the defaults if you wanted to. If you're going to use the defaults, Cisco has some great documentation on those also. But we're going to do a crypto Ike V2. Let's set up our policy first. We'll call the policy, I like to do everything caps. We'll do flex underscore policy. And let's do, let me make a proposal first. So let's do crypto Ike V2 proposal. And I'll call this flex prop. And let's just do for encryption, we'll do AES CBC 256. And then for integrity, we'll do, how about SHA-256? Why not? We'll set the group as, let's just do group 5. PFR as SHA-256 also. And then let's do crypto Ike V2. I warn you guys right now, when you set it all up manually and you don't use the defaults, there's a lot of typing. But at least you'll see all the components that go and how they sort of fit together. But it will make this video longer, especially when I stop and ramble like this. So we'll say, we'll do a crypto Ike V2, and we'll set up our policy now. We'll call the policy flex underscore POL. We'll set the proposal we just created, flex prop. We're going to match, helps me type match right. FVRF any, which is totally fine, and that's it. Okay, let's do crypto Ike V2. We'll set up an authorization policy. We'll say flex auth underscore POL, and here we're gonna say we'll say route, because remember with Ike V2 we can push routing out to our peers. So we're going to push a route out to the interface, so route set interface. We're also going to push on the hub, we're going to push a /8 out for all 10 networks. So we'll say route set access list, which I haven't created yet. And the access list of choice will be flex route. We'll set default domain to be pushed out as nerd.local. Any other settings I want to set? We're going to set up a pool because I want my spoke routers to get dynamic IPs on their tunnel interfaces. So we'll set up a pool. The pool will be flex pool. Let's make that pool really quick. That's IP local pool, flex pool, and 10, 255, 255. We'll start at 10 and we'll end at, how about 254? Why not? You'll notice this subnet is the same subnet as my loopback 0. Technically it doesn't have to be, but I'm going to do it that way. Alright, so let's do show run. Let's do a section on Ike V2 really quick, see where we're at. Most of this is copy paste that we'll be able to put on the spokes with some slight modifications. Alright, so we have our authorization policy, we have our proposal, we have our Ike V2 policy. Now we have to make an Ike V2 profile. the crypto Ike V2 Profile. We'll call this Flex PO Prof. How about Flex Prof? All right, we're going to be matching the identity of our remote sites for their FQDN, and the FQDN, we're just looking for the domain, so the domain will be nerd.local. And then our local, identity local, and we're going to set our FQDN here to be hub.nerd.local, because we're going to have this same match identity on the spokes also, so it's going to be looking for this bit right here to match on this policy, or this profile rather. Cool. And we also need to set our authentication. So remember with Ike V2, we can do symmetrical or asymmetrical authentication. We're going to have our local authentication method to be RSA SIG, because we're doing our we're doing our certificate-based authentication. The remote authentication will be the same. Let's see what else we need. We have to set up our Pki Trust Point. The trust point we set up earlier with our certificates was EntCA. We're going to do a AAA authorization group for cert list, and then just use the default list, and we're going to tie that to the authorization policy we set up above to make sure that this route set interface and access list gets pushed out, and so that this pool of addresses gets pushed out. So we'll copy that. All right, let's see where we're at. We'll do show run section Ike V2 profile. How's it looking? So we have our match identity, we have our local identity, we have authentication, we have our Pki Trust Point, we have our AAA authorization group, so that all of our Ike V2 authorization rules get pushed out. We need to tie this to a virtual template, which I haven't created yet. We're going to use virtual template 1. Sweet. Okay. Let's see. Things that I have forgotten. I haven't set up the access list yet for what routes are going to get pushed out. Let's see. So let's do that really quick. I think we called it flex route. I say we, but I know it's me. Right? Yeah. Okay. So let's do IP access list. It's just a standard access list. We're going to say flex route, and we're going to push out a /8 for all 10 networks. Because you'll notice with us having the ability to use Ike V2 to push these routes out, we don't actually need to run dynamic routing. Though for fun, I might go through and set up EIGRP, but I also might just do that in the next video. All right, so we have that. What else have we forgotten to do? I haven't set up a transform set or an IPsec profile yet, so let's do that. So crypto IPsec transform sets. We'll say FlexTS, and I'll call it with ESP AES 256. Apparently I like that. And ESP SHA, let's get crazy, SHA 512. No, I'm just kidding. That'll actually be terrible performance on this little virtual device. 256 is still pretty bad, but that's fine. And then we're going to put this in mode transport. Then we have to make our profile. So crypto IPsec profile. This is our Flex IPsec. And we're going to set transform set. We just made that above as FlexTS. And we're going to set our Ike V2 profile to be Flex Prof. All that looks good. Cool. So let's set up our virtual template. We'll say int virtual template 1, type is tunnel. We're going to make it IPN numbered, loopback 0. And then pardon me. For these dynamic spoke-to-spoke tunnels, it's going to use some familiar technology to you guys. We're going to do IP NHRP network ID. I'll do 47884. We'll do IP NHRP redirect. And we're going to do tunnel protection, IPsec, profile, what do we call it? Flex underscore IPsec. Look here. So I got the message. ICCamp is on. So it looks like we're good. Let's see what all config I can borrow for the spokes, and then I'll modify it. I'll put it all on site 2, bring the tunnel up, and then I'll fast forward as we go through and configure 3, 4, and 5, so you don't have to sit through all that. So let's do show run section Ike V2. And I'm just going to take pretty much all of this. Pop that in there, and then the things that are going to change. On the spokes, the authorization profile is just going to have route set interface and route set access list, and the flex route access list will be site specific. It won't be a full /8 like it is up on the hub. So we'll change that. Put that right above. That's going to be IP access list, standard, flex route, permit 10.0, and I think, what did we say? 10.0.20 on site 2. So 10.0.2.0, just a /24 there. Let's see what else. Proposal's good. Policy looks good. Profile needs to change so that the FQDM we're going to say is S2. Everything else looks like it's the same. Still virtual template 1. And then I'll do the specific client config just on 2 and steal all that. Oh, and we have to get the IPsec stuff. Show run section IPsec. Should give me more than I need actually, but it's fine. So there's our transform set. There's our profile. Cool. All right, so this is the stuff from the hub that we're going to use all on site 2. Let me see if I can... sorry I can't zoom in. I'm sure that I could zoom in. Here, is it down here? I need to get better with Text Wrangler is a problem. So let me just zoom in a good bit so you guys can see what the config looks like. So you can pause there if you wanted to look over what we're taking from the hub and putting onto the spoke. And then there's going to be some extra config on the spoke, but then after we configure one spoke, we can pretty much just take that config, modify the FQDN, and then paste it onto every other spoke. So it's a really, really awesome process that can be easily templated. Since you don't have to change IP addresses, oh, I'm sorry, you have to change your access list up here, but you don't have to change any IP addresses or anything like that. All right, so we're going to take all of this, and I'm going to paste it in. I will undoubtedly get some errors. Oh no, it's good. Cool. All right, so let's set up our tunnel interface on the spokes. We're gonna have a tunnel interface and a virtual template. And you'll see how those two play together. The tunnel, well, I'll tell you right now. The tunnel interface will be communication back to the hub, and then the virtual template will be for the dynamic tunnels spoke to spoke. So we're gonna say int tunnel 0. IP address is negotiated because remember the hub has a pool set up for us. We're going to do tunnel source is gig00. That's our WAN interface. I'm not going to set tunnel destination yet. I will be setting it tunnel destination dynamic when the config's done. But let me just get through everything else first. So I'll say IP NHRP. The network ID we used was 47884. IP NHRP redirects are enabled. And then shortcut, and then we're going to, instead of the typical DMVPN v3 way of doing it, it's actually IP NHRP shortcut virtual template, and then virtual template number 1 is what we'll be using. Take a look at that. Looks pretty good so far. Now, mind you, there's enhancements that you'll want to do, like setting your IP MTU and doing your TCP adjust, or adjust MSS. But we're not going to do any of that in this demo video. So this is just going to be us getting it working, and then I'll leave the fine tuning to you guys before you try and roll this out into your lab. All right, so we have all that. Let's set our tunnel protection. IPsec. The profile created was Flex IPsec. All right, so the other thing that we can do on your spokes, you can either set the destination and actually point it directly to the hub, or if your hub has dynamic IP addresses, or has a dynamic IP, or if you have multiple hubs, you can use the crypto or the FlexVPN client mode. So we're going to do that because I think that's way cooler. So we're going to do crypto Ike V2 client FlexVPN. We're going to give this a name, so we'll call it spokes. We're going to say connect is auto. That's actually on by default. Don't need that. Client connect. We'll be using tunnel interface 0 for our connect. And then we specify our peer, which is the hub. And then notice you can put in sequence numbers so you can prioritize if you have multiple hubs, but we're going to do peer 1. You can put in FQDN, so if it had a dynamic IP and you had some sort of dynamic DNS so that when the IP changed, it got updated on the internet, you could do peer 1, type in the host name of that, which maybe it was hub.nerd.com, and then what you'd want to do, because if you just press enter here, what iOS does, it does a lookup on that, and then it puts the IP address that it resolves to into the config. But if you wanted to do persistent lookups on that and just and always query what the host name is, or what the IP address is. Oops. Sorry. If you did peer 1 FQDN, then put the fully qualified domain in. After that, you can do dynamic, and now it'll store that in your running config just as hub.nerd.local. We're not going to have to do that. So let's just do peer 1 is 200.0.1.1. We're not going to track it or anything. So let's do show run section FlexVPN. Make sure that our client connect profile looks good. See, yeah, connect auto is on by default, so we don't actually need to do that. So that looks good. Let's do show run int tunnel 0. And if you're wondering why we haven't seen any traffic yet, or the interface trying to come up or anything, it's because the tunnel destination is still unset. So let's do int virtual template. This will be for our dynamic spoke-to-spoke tunnels. So int virtual template 1 type is tunnel. We'll do IP unnumbered from tunnel 0. And then we're going to say IP NHRP network ID is 47884, IP NHRP redirect, and shortcut, and then we still do the shortcut to virtual template 1 because we'll have these dynamic virtual access interfaces that come up for our spoke-to-spoke tunnels. Again, do tunnel protection, IPsec, profile, flex IPsec. Take a look at that config, so it all looks good. All right, so let's go to int tunnel 0. So since we have this Ike V2 client set up with our peer in there, we don't actually have to set a tunnel destination to a static address. We just do tunnel destination is dynamic, and we'll get a prompt in the terminal saying that it's trying to connect. And with any luck, we should see this come right up. I'm gonna look through my configs really quick. Okay. Press enter. Let's see how it goes. Okay, hold on one second. Take a look. Hold on. So it tried to do a revocation check on that cert. So let's see. I thought we had that disabled. Let's do show run section PKI. Okay. So this has to be set to none. So let's shut our tunnel interface first and make sure. Otherwise it keeps trying to validate whether the certificate is still valid, which we don't want it to do, because it has no actual access to the certificate authority to do a look to see if the certificate's still valid. So revocation check, none. Let's make sure that's set on the hub also. I'm assuming that it is because we didn't get any of the output. Wait. Yeah, set here. So I must have not had it configured on the spokes for some reason. So let me just get that ready. We'll drop that on the other spokes. You don't have to watch that part though. I'll speed the video up there. I'm just getting it ready for myself. That there. Okay, so that's for me later. All right, so now that we have the revocation check is set to none, we'll go back into tunnel 0. We'll no shut the interface, and now with any luck we should see it come up. Looks good. Tunnel interface is up. Usually takes a hot second here. Virtual access came up, and we should get a console prompt whenever the dynamic IP is assigned. Nothing yet. There we go, just took a hot second. All right, so then we got this notice here, line protocol came up, and then we have this output from our FlexVPN client config saying that this is our public IP, 2.0.0.5, and then the hub assigned us 10.255.255.14. So I should be able to do show IP route static, and we have a static route to 10.0.20, which was injected by site 2, and then we have our host route to site 2, 10.255.255.14. So I'll come over here, show IP route static. We should have a /8 route in our routing table. Yep, there's our /8, and then we have a static route 10.255.255.1 back to the hub. We'll try and ping the hub. All right, that looks good. We'll try and ping 10.0.1.1, and we'll source that from our gig01. All right, that looks good. Okay. So now that that's all set up, I'm going to speed the video up, and then I'll get this configured on all the spokes. Again, it's largely copy and paste. The only thing that has to change is the identity that we have set in our Flex profile. I'm also going to go through on all the spokes and make sure that under the Pki Trust Point for our enterprise CA, that revocation is set to none. And come back really quick. I'm actually going to take this config directly from site 2, the interface config for tunnel 0 and for the virtual template, and pop that all in here. Because we can use all of this also. Because by and large, you should be able to take your spoke configs, and again, minus changing the FQDN, be able to copy and paste and template this whole thing out so that you have one character change, or I guess two because of your Ike V2 routing, but have 2 character changes really, and just paste this all on. So I'm going to take that, and then I also need the client config since we're doing tunnel destination dynamic. And we're going to pop this in right after the actual tunnel setup. So all it looks good. Okay, I'm going to go back to speeding the video up. And back normal speed. Okay, cool. So let's take a look at our show IP route static, and Our Ike V2 routing should be looking good. So we have routes to site 2, 3, 4, and 5. And then, of course, corresponding routes to their interfaces because of our Ike V2 authorization policy, where we're setting a route to the interface and to an access list. So that all looks good. We'll try and ping just hub to spoke. So let's go 2.2, 3.3, 4.4, 5.5. Looks good. All right, so the dynamic spoke-to-spoke tunnels are already set up to work, so we can go ahead and bring one up. Again, if I do a show IP route, let's look at static. You'll see right now the only route I would have to 10.033, for example, would be the /8 going up to the hub. If I do a show crypto Ike V2 SA, you'll see I have a single security association. And if I do a show IP int brief, you'll see I have this virtual template but no virtual access interfaces. And that'll change as soon as I do a ping to 10.033. Wait for it. See virtual access comes up. You'll notice how the ping was a little bit slow. Now it's significantly faster. If I do show crypto Ike V2 SA, you'll see I have a new security association. This one forms over to site 3. If I do a show IP route static, you'll see I get these nice next hop override routes for 10.0.3.0. If I go over to R3, you can see a virtual access interface came up on this side. I can just show crypto Ipsec. I'm sorry, show crypto Ike V2 SA. I have my SA right there. I just show IP route, and I have my override to get back to tunnel 0. Now, if I ping and do a source from my gig 01, that'll actually get the route injected into site 3. I'm sorry, it was actually already there. Pardon, I just didn't see the next hop override. All right, so that's about it, guys. We have dynamic spoke-to-spoke tunnels. We have Ike V2 routing. You can do dynamic routing over this, so if you didn't want to do this route set access list, you don't have to inject routes via Ike V2. You could run EIGRP, BGP. My only thing about EIGRP that I will mention is you want to make sure this is like the best sort of scenario where you absolutely should be doing passive interface default. Otherwise, you'll start forming adjacencies over your dynamic virtual access interfaces, and that can make things act really, really weird. So best bet is do, under your EIGRP config, do passive interface default, and then just no passive to tunnel interfaces. And you only really have to do that with the spokes. The other huge benefit to Ike V2 if you're running EIGRP, as opposed to something like DMVPN, is if you look on the hub here, we don't have to do no split horizon, because if I do show IP route, you'll notice these routes are all going over separate virtual access interfaces, which EIGRP will see as separate interfaces, so it's not a split horizon issue. So your EIGRP config is super simple. But again, that's all for this one, guys. Follow-up video will probably be on how to set up an iOS router to be a certificate authority, and then I might do some demo with how to set up dynamic routing over Ike V2 or over FlexVPN.